Hi everyone, welcome to the Week 5 Laboratory Tutorial Section 4 for the Programming Fundamentals and Application course, and I am Teaching Assistant Yang Tao. And in this laboratory, we are going to discuss the control flow and especially conditional statement in the Python programming language. And I assume all of you have learned something about the conditional statement in the lecture section. So in this laboratory, we're going to dive into the specific question directly. And here comes the first question. The first question is about write a program to check if a given number is a prime or not. And to solve this, we are going to firstly figure out what is a prime number. And in the Wikipedia, a prime number is like a natural number greater than 1 that is not a product of two smaller natural numbers. For example, 2, 3, 5, and 7. And to solve this problem, the first thing is to get an input from the user. So we use the input function. And the point is that we have to convert the data type into an int type. It's because the default input type is actually a string. And after that, we come to the processing logic. According to the definition, we wanted a natural number that are greater than 1, so we are going to use the if statement to check that first. If the number is large and is actually larger than 1, we're going to the main branch, the processing logic. And if it doesn't fit that condition, which is for those numbers that are smaller and equal than 0, we come to the else branch, and those numbers are actually absolutely not a prime. So we print out the message, and for those numbers that are larger than 1, we are going to check the following statement. If there is any two smaller natural numbers that could be that the product of that two factor could be exactly the original number, then it is not a prime number. So we use a for iteration to check this, and we start from 2 to number minus 1. It's because every number could absolutely be decomposed into 1 and the number itself, and we should exclude that first. And for those numbers that are from 2 to number minus 1, we check if the product of these two factors are exactly the original number, and this is actually implemented by compute the residual of the number divided by the smaller number I. And if the residual is exactly 0, then the original number is the product of these two factors. So we print out a message that print out that we already found the two smaller factor of the original number, so it actually not a prime number. And we break out of this iteration because we already found that two factor. And if finally we couldn't find the two smaller factor, then it is okay to say that the number is actually a prime number. So we use this else branch, which means that if this for iteration is going through normally and it doesn't break out of this iteration immediately, it will naturally go into the else branch, and finally it print out that message print out a message that this number is a prime, and we run example like we input 1024, which is actually definitely not a prime number, is because it's an even number, right? So it print out a message that it is not a prime number, and so it function well, and we try again with a with number like 59, and 59 is probably a prime number. So let's check the result. It output that 59 is a prime, so this program working well. It's okay to say the program working well. Question is about writing the program to check the entered number is an Armstrong number or not. And of course, we should define the Armstrong number first. So according to Wikipedia, Armstrong number is a number that is the sum of its own digit, each raised to the power of the number or the length of its original digit. So firstly, we use the combination of input function and int function to get input from the user and convert it into an integer data type. And then we initialize a variable to store the summation of the later process. It should be noted that we use the length function to calculate the number of the digit in the number. And the problem is that we have to convert that back into a string data type. It's because the length function could only work well with a string. You can't calculate the length of integer or float data type. And later we do the conditional statement, but we use the while iteration instead of only use the if-else statement. It's because we have to like iteratively check every digit of the original number. So we initialize a temporary variable to store the every digit of the original number, and get a digit by like divided the temporary variable by 10 and get residual, and we'll raise every digit to the power of number of digit, and we divided the temperature variable by 10, and we do this as one iteration. It's a little bit complicated, but you could like print out a message, print out every time you print out a digit to see like debug the result. And finally, we use an if statement to check if the like the summation equals to the original number, and in this condition it should be an Armstrong number, and otherwise it's actually not an Armstrong number. It's like that easy. So we check like, let's see the example, like 1634 is actually an Armstrong number, so we input that as a example. Let's try it, and it print out like 4361. So we actually could see through the iteration process. It goes through the the unit digit, then to the 10 digit, then to the 100 digit, and 1000. It's like that from the smaller to larger, like from the right side to the left side, and actually calculate the raise every digit to the power of to the power of 4 in this example, and finally the result is that the number is a Armstrong number. By the way, a very interesting point about the question 2 is that the iteration over integer data type is not that convenient in Python. and more intuitively we do the iteration over a string type like this version. We leave the original data type and we don't do the data conversion to leave the original number variable actually a string data type, and we could print that out to check. And it's like all the same, and we calculate the length of the string data type, and actually we this time we use a for iteration, and we only need this 2 line to check if the to do the summation and read every digit of the original number to the power of the length. We could print that out to check the iteration process, and we finally check if the summation equals the original number. And we run the program. We input 1634. We could see that firstly the input data type is a string, and secondly the iteration direction is actually from the left to the right, which is different from our previous program. And we also output the correct result. And we could also use a reversed function to reverse the direction of the string and to keep the same direction, to keep the same iteration direction with the previous program, like this. 1030. Okay, so this time we maintain the direction from the unit digit to the 1000 digit from right to left. So it's like that. For question 1 and 2, it's much more easier to tackle the question 3, which asked us to write a Python program to check the year for a leap year. And the definition of the leap year is actually if the year is divisible by 4, then it should not be a century year, and which is to say that should not be divisible by 100. And if the year is a century year, then it should be divided by 400. We could write actually a nested if statement like this. The first condition is that if it could be could be divisible by 400, then it absolutely a leap year. Otherwise, we check if the year is divisible by 4, and divisible by 4, then we check if it is a century year or not. If is, then it's not a leap year. If not, if actually it's a non-century year, then it should be a leap year. So that's the very fundamental version of this question. And later we could do a combination of this different condition and provide a much more simplified version. We could do the simplification by combining this different conditional branch. This is if this is the A branch, and this also a branch, and this is the B branch, and this is also the B branch. We could see that there's only two kind of output of this program. So we combine this true branch and combine this 2 branch, and we could get a simplified version like this by using the using the OR operator to concatenate these two conditional statement, and use the AND condition to connect this. So this version is much more easier than the previous version, and let's check the result of this. 2024 should be a leap year, so it output correctly. After the question 1, 2, 3, the question 4 should be also very easy. Question 4 is about writing a Python program to check if the entered character is a vowel or a consonant. And for this question, we actually don't have this sort of rules to define the conditional statement like the question before. So we are going to use the enumeration. It's because, as we know, the vowel, there's only 5 kinds of vowel: A, E, O, I, U, and we could just enumerate them like this. And otherwise, the other condition, the character should be a consonant. So the only thing we need to pay attention is that the vowel could appears in lower cases or appears in the upper cases. So we actually have 10 kinds of condition here, and we use the OR operator to concatenate them. There's a much more easier version of this this question. We could revise this program by doing this. If the character in A, E, O, I, U, we use the we use the lower method, which is like a class function of the string data type. Use it to convert the character into the lowercase first, and then we check that. Use the in statement, the in operator, to check if the character is actually in the list of the this 5 vowels. So if it is either one of these 2 vowels, then it fits the first condition and it's actually a vowel. So we check the output of this program. A is absolutely a vowel, and J is absolutely a consonant. So the answer is correct. Comes to the last question of this lab, which is question 5. And question 5 is a above average program, which includes a lot of conditions to check. It says that a company insures its drivers in the following cases: if the driver is married, or if the driver is unmarried, male, and above 30 years of age. And if the driver is unmarried, female, and above 25 years of age. And in all other cases, the driver is not insured. So we're going to write a Python program to receive the marital status, sex, and age of the driver as the inputs. And we could write this to receive the age, sex, and status as 3 variables from the user input first. And for the conditional checking part, I write 3 versions of the if-else statement. It's actually 3 different ways to use the if-else statement. And all of the 3 versions, you have gone through this 3 versions of usage in following question before, actually. So the first version is a very nested version. I use a if-else statement and use another the second layers of if-else statement inside the original one to check the to check the sex, and then the age, actually sequentially. So we actually got this three layers of if-else statement. So it actually could function well, but it doesn't look beautiful. So we could do a simplification and use the elif and else statement instead of a nested if-else. So it could be simplified like this. So we only got this 1, 2, 3, 4 kind of cases. It's like to combine the if statement inside of the else statement into a elif, and could be much more could look cleaner and clear and simplified. And also it could be concatenated. You could concatenate the condition into an even more simplified one, and we only have this two kind of condition, because in the first lines of condition, it's a combination of actually three types of condition, and it's concatenated with the or and operator. Even though the three types of three versions of the program have different program structure, but it actually could output this same result. Let's try with the actually a 30 years old age male and married driver. So the output is the driver should be insured. Let's try it with another 28 years old female unmarried driver. We could tell that in this case the driver should be insured as well. So we could see that the three version of the conditional statement is actually equivalent. So that's all of the lab content today, and I wish the Phi program could offer some could actually provide some knowledge for you about the conditional statement in the Python programming language. Thank you.